let us focus on this equation right there. It's the easiest way to do it. Suppose x is to the left of negative 2. If x is to the left of negative 2, we're going to say if x is less than negative 2, then this number is going to be a negative number. This number will be a negative number. Multiply two negatives together. This is source positive. You get a positive number. So then c prime of x is positive. Now suppose x is between negative 2 and negative 3. That means if x is to the left of here, c prime is positive. Now if x is between negative 2 and 3, that's x is between here and here. If, we write it this way, if negative 2 is less than x, oh, I'm sorry, I don't leave out the step. If x equals negative 2, we already decided c prime of x was 0. Now, if x is between negative 2 and 3, that means negative 2 is less than x, less than 3. That is, x is between here and here. If x is between negative 2 and 3, well, this is going to be positive, because this number is going to be like negative 1, for example. So this will be positive. This will still be negative. You multiply a positive, you get a negative. So we see c prime of x will be negative. Maybe I should write POS here, just to be consistent.
Right.
Now let's consider, what if x is now at 3? If x equals 3, we already decided c prime of x is again 0. And if x is greater than 3, that's on the extreme right to the right of that point, then this is positive and this is positive. So there's two positives multiplied, so c prime of x is positive. This means we can draw, I'm sorry, I have to do POS, thank you. To be consistent, c prime of x is positive. That means we can draw a little picture here. Here's our picture. Here, the derivative is positive. So the derivative is like this. Like here, it's going up. Here, the derivative is 0. And here, the derivative is negative. This line, this is a tangent line. This tangent line has a positive slope. The derivative is the slope of the tangent line. This tangent line has 0 slope. This tangent line has negative slope. So whenever we find that we have the derivative is decreasing, that's right here. Derivative is decreasing. That means we have a relative maximum. So we've definitely verified that nothing funny is happening. This point definitely is a relative maximum because the derivative starts positive, goes to 0, then becomes negative. Now, in this scenario, that includes these 3 cases. Now, take the next 3 cases. I'll use another color. Here, the derivative has a negative slope. It still has a negative slope down here. It still has a negative slope. The slope of the derivative is 0. Tangent line is 0. I didn't say that right. The derivative, which is the slope of the tangent line, is a negative number here because this line has a negative slope. Because the tangent line has a 0 slope. This tangent line has a positive slope. So from here to here, we see the derivative is negative, 0, positive. Derivative is increasing. 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 So derivative is decreasing. What does that mean? Derivative is decreasing. That means we have a relative maximum. Derivative is increasing. This means we have a relative minimum. And if there's a relative maximum, a relative minimum, and the function is nice and continuous, has a derivative everywhere, then obviously it has to go from concave down to concave up. It has to be in between a point of inflection. Therefore, this point, 1/2, negative 4 1/4, is indeed a point of inflection. And then we are done with this problem.